So welcome. This morning I want to talk a little bit about Lattice, which I'm calling a cloud-native platform for your Spring applications. We talked about another cloud-native platform for Spring applications last night. And we're going to see how those things relate, as well as how you can take advantage of this. Also, my book is out there floating around. It's free in every form that you can get it. You can always get the ebook at the link there. But I believe we have several hundred copies at the Pivotal booths, and I'm also going to sign these for a little while on Wednesday afternoon if you're interested in that and want to stop by and chat for a few seconds. We'll do that. So before I get deep into what Lattice is, I want to talk a little bit more about cloud-native applications. We positioned that a little bit last night, but I want to do it again just to kind of have a firm foundation that we can start from. So I was working with my good friend and colleague Andrew Schaefer on what is a one-sentence definition of a cloud-native application. And we went back and forth for a little bit, and this is essentially what we came up with. This is much more his idea than it is mine, but I like it quite a lot. So cloud-native applications compose simple patterns with predictable performance, scaling, security, failure, and other characteristics to create solutions to complex problems that can be quickly and flexibly adapted to take advantage of new information. This is the thing that we're talking about. This is the thing that we're trying to enable you to build throughout this entire show. And I want to break this down a little bit. So when we say simple patterns, what do we mean? So here are some simple patterns that actually happen to have fairly predictable characteristics associated with them. We know that when we follow these things, we start to get similar results when we apply these patterns. The first of those is 12-factor. I'm not going to delve into 12-factor. There's a whole talk on 12-factor. Talked about it a little bit last night, but these 12 principles of design that if you follow them in your applications, they actually behave very well in cloud environments. Rest is pretty simple, right? You've got 4 main verbs. There's some other things floating around in there, but 4 main things that we want to do, and each of those things has well-defined semantics, and we can structure applications around those verbs, and we can get some pretty reliable and predictable behavior. Pipes and filters has been around for a very long time. You've got filters. What are filters? Filters are programs. They process and they aggregate and they transform things. And then pipes are dumb little things that simply join things together. And we can see that pattern emerge in architectures all over the industry. You've got service discovery. Things register. Things ask the registry where those things are. I discover them. I talk to them. And there are different service discovery implementations, Eureka being the one that we're going to talk about a lot this week, that have very nice predictable behavior characteristics around availability. And then circuit breakers, a pattern that didn't even start in this industry, but a pattern that we used in electrical circuitry. When something would go wrong, we wanted to prevent damage from encountering the rest of the system. We abstract that idea away into software, and now we have something that when something goes wrong in our systems, we prevent that from breaking the rest of the system. And this isn't a complete list. This is far from a complete list, but I just wanted to give you some examples of what we're talking about. And you're going to hear more about these all throughout the week. Complex problems. Well, there's a lot of companies out there that are employing cloud-native architectures that are solving problems with them. But if you start to look at these companies, while they feel like they're a little bit different from your traditional enterprise companies, you look at the problems that they're trying to solve, they're solving the same problems that we have. They're solving the problems of being able to deliver software reliably and quickly and in such a way that customers can interact with you pretty much wherever they are, whenever they want. Well, quick and flexible adaptation, that's where microservices come in. What are microservices? Lots of definitions of these floating around. This is not my definition. This is Adrian Cockcroft's definition, but I like it a lot. You still have service-oriented architecture, but you've got service-oriented architecture bookended by two very important things. One, loose coupling. What's a loosely coupled service look like? It's a service that I can deploy anytime that I want, and I don't have to coordinate with all of the other people that are developing services. Now that sounds hard, but you would have to agree that if we could actually achieve that, that would be a powerful thing. Well, one of the ways that we can achieve that is with the other bookend, which is bounded context. Bounded context comes from domain-driven design. I'm not going to go deep into that as well, but pick up one of the domain-driven design books and read more about it. But essentially the idea that I don't know anything about the surrounding services other than their API. I don't get to go around the API and talk directly to the database, learn things about their internals, because what happens when I start to do that and I start to make decisions based on those hidden internals, I start to couple myself to those internals, and there goes loose coupling, and there goes the ability for me to independently deploy things. So in a sense, what we're using microservices to do is to keep things that should be separated all throughout their life cycle. Now the problem with microservices is that you end up building these huge distributed systems. You know, the better you get at microservices, the more problems that you have. If you spend any time with distributed systems, you know that the probability of any part of the system failing increases exponentially with the number of nodes. And so we end up with this tension between microservices enabling us to deliver faster and scale independently, but also making it more likely that something's going to fail. So we have to figure out how are we going to build reliable systems from unreliable components. But if we can do that, then we can quickly and flexibly adapt because we have all of these things able to evolve independently. Okay? So then how do we continue to deliver that same iterative experience? So this is where continuous delivery comes into play. Your cloud-native companies, they practice continuous delivery. What does that mean? Well, it may help to invert the phrase or perhaps use proper grammar. Deliver continuously. It's not enough to deploy something. Deploying something is just day one. You have to deploy again and again and again and again. And when you do that, you can't break stuff. And that's day 2 and day 3 and day 4 and so on. And so operational discipline becomes key to cloud native. If it costs you anything to run something at all, then if you look at the time that an application, and we know that our applications in the enterprise, they essentially feel like they live forever. Once you've built something, it never goes away, ever. On some time scale, not that far out, the operational cost of the thing far dwarfs the creation cost of the thing. And if that cost is high, then that day comes really, really quickly. So how much does it cost you to deploy something? And then multiply that by hundreds of deployments per day, and you realize that very quickly you're going to end up spending all of your money, and you don't actually get to develop anything anymore. And nobody wants to do that. So we have to figure out how to solve this problem. And ultimately, you're going to need a platform. It's not really an option. You need some platform that enables you to continuously deliver software. Everybody's going to have one. If you don't have one, you're probably not alive. So the question is not, are we going to have one of these things? The question is, how and where are we going to get that thing? Now, we talked about, a little bit ahead of myself, we talked about this stuff last night. The vast majority of the week is going to focus on the first 2 items, so I'm not going to talk about those much at all. I want to focus in on the third one. And I actually want to drill down into Cloud Foundry a little bit, just to give you a taste of what's going on under the hood. So we lift the hood and we find all this mess inside. What is that? Well, you've got a bunch of components floating around in here, and I'm not going to tell you what all this is right now, other than to say you've got three major sets of functionality that you're looking at. You've got the idea of scheduling workloads in containers, and that's in the blue area, and we're going to spend a decent amount of time on that. You've got the idea of taking all those things that are running in containers and getting traffic to them, and then getting metrics and logs and other introspection out of them. That's the stuff in yellow. And then you've got the idea of identity and tenancy and security. That's in the red. If you have all this stuff, you can solve a bunch of problems. And for some reason, I keep advancing 2 slides every time I click the button, so I'm going to stop clicking that button. So what problems does it solve? A lot of stuff. Things like role-based access, being able to run code on command, routing traffic, reading and writing persistent data, measuring things, detecting and determining what failures are, recovering from those failures. The idea that this thing doesn't just work today, but it also works tomorrow. And you have to solve all these problems in your organization somewhere, somehow. You don't have a choice. And I bet a lot of you have spent a lot of time not writing code that you would like to write and trying to solve these problems so that that code that you wrote actually makes it off of your laptop and into production somewhere where users actually use it. Okay, well, if we take that and we drill down a little bit deeper, we're going to find that thing in the blue. And that thing in the blue is called Diego. And I'm not going to go into the history of where Diego got his name, but you probably, if you're familiar with Go, the programming language, and Gophers, you know why he's on the screen, because all of this stuff happens to be written in that language. What is Diego? Diego is a distributed system that orchestrates containerized workloads. Okay, I have no idea what that means. Let's break that down a little bit. So here's the distributed system. You've got 3 major components here. The first component is a thing called a cell, and a cell is a highly available container execution node. It is a thing that runs containers. That is its job. That is all that it cares about doing. You then have a thing called a brain. The brain's job is to schedule workloads. So, hey, I have some work I want to do. I want it to end up over here on this cell and run. And this brain's job is to actually orchestrate and make that happen. And then you have health monitoring. Not only do I want things to run, but I want them to keep running. And so its job is to make sure that all the things keep running. Now, the way these 2 things coordinate primarily is through this thing called the BBS. And the BBS is a consistent shared state store. It's where we keep up with what is actually true in the system right now, and what are the things that we want to be true, and that happens to be backed by etcd. Okay, so we have this thing that can run containers, but it's probably important that we understand, okay, well, what in the world are containers? Because when I use the word container in a setting like this, probably the first thing that most of us think about is a servlet container. So I'm not talking about that. I'm talking about something else. So what are containers? Containers are an operating system feature, and we happen to be talking about that particular operating system feature in Linux that's built into the kernel that does 3 primary things for me. So the first thing that it does is isolate resources. So I have a bunch of computational power sitting somewhere, and I want to share that amongst a group of processes, and I want to make sure that each of them gets some fair share that I've decided of access to the CPU. Same thing with memory, same thing with I/O. Now this is the thing that we have done up until this point, most of us with virtual machines. We wanted to take a big physical box that was sitting there mostly idle and pack more stuff into it, but we didn't want to pack it in such a way that one process could unfairly steal from another. And so the hypervisor was doing that for us. Now we have this thing in the kernel that's doing this, and that happens to be called control groups, or C groups for short. The other thing that we used VMs to do was to isolate visibility or access. So it's not enough just to make sure that I only get so much CPU or so much memory, so much I/O, but I also want to make sure that I process is only able to see the things that it should see. In fact, it would be great if your process as customer A doesn't even know that customer B's process exists, and vice versa. And we can say the same things about networking and the same things about what mount points a particular process can see, so we can know where it can read and write data. And so we call this visibility or access isolation, and we do that with what's called namespaces. And so now we have two things that give us abilities to make a process essentially believe that it's living on this isolated machine, when in fact it's actually sharing space with a bunch of other processes on a single machine, and yet we're doing this without the overhead of a guest operating system. So that's pretty cool. So what's the last thing that we need? Well, we have this set of walls that we can build around resources. We have this set of walls that we can build around visibility. Well, now we need something to run. So we need some data. We need some bits that we want to execute. And so we have this thing called the union file system. And the union file system is just a set of layers that build up a current state of a file system, and each of those layers is immutable. You can think of this like you think of your version control system. You start a new Git repository, you make your first commit, that is the parent, and then you make a new commit, that becomes a child, and it points back to its parent, and you do that over time, and eventually you get to the point where you have tens and hundreds of commits, and you want to know, what does my working tree look like right now? Well, it's the result of Git playing back all of those commits from beginning until now. And so the same exact type of thing is happening inside the union file system. And so when you run something in a container, you're starting with some base, and then you're laying layers of code on top of that. And eventually you want to get to the point where you can do some work, so we layer this one last layer on the top that I actually get to write to. So this is what containers look like. But notice I haven't said anything about Docker yet. I'm sure at least some of you were wondering, when is he going to talk about Docker? He's saying all this stuff about containers, but he's not talking about Docker. So what is Docker? Well, Docker is actually all of the stuff that I just talked about, plus a really super easy to grok user experience. So containers have actually been around for a really long time. Docker we've only started hearing about in the last couple years. The reason for that, and the reason that we started thinking about these containers, even though they've existed for some time, is because before Docker came around, you basically had to have a PhD in the Linux kernel to use them. And now you don't. They're very simple. About the same time that Docker was being born, there was this other container orchestrator being born, and its name was Warden. And Warden also worked with C groups and namespaces and union file systems. And it got rewritten in Go as well. When you rewrite something in Go, you change something to a G. And so Warden became Garden. And so we have this execution. This was in the top of the blue section of Diego, this thing called the Garden API. And the Garden API is a thing that knows how to run containers, but is agnostic to what the actual backend looks like. So what we're normally doing when we run things in containers is we're using a backend to Garden called Garden Linux. And so I want to spin up a workload inside of a container. I orchestrate some C groups and namespaces inside Garden Linux, and I get this process running in a container. But the thing that is actually asking for that workload to be run, it has no idea that that's being run on Linux. It has no idea that that's being run through Garden Linux. All it knows is ask the Garden API to run a thing. And I can ask the Garden API to run me in copies of that thing, and it will happily comply. Now, because Docker, again, is a user experience, in fact, at the levels that really count, there's really nothing fundamentally different about Docker than Garden. And so as it turns out, and I'm borrowing a statement that was made yesterday because I thought it was awesome, Docker grows in this garden as well. So I can take a Docker image and Docker metadata. Docker image is that set of layers. Docker metadata is the thing that I want to run and how I want to run it. And I can tell Garden, hey, don't run this Garden image, actually run this Docker image instead. And it'll say, okay, run in copies of it. Fine, I'll do that. Now, there's this big open area over here because there's this big gaping hole in that, well, we're only able to do this with Linux. Well, as it turns out, we can also do this with Windows. So there's also a backend for Garden called Garden Windows that allows us to do, today, a reasonable level of orchestration of Windows processes inside of containers. Microsoft is continuing to invest in this space. They're collaborating with Docker, they're collaborating with us, and in Windows 2016, the container story is actually going to be quite good. I wanted to show you some .NET applications actually interacting with some Spring applications on the platform, but time did not allow for me making that happen. But I wanted to tell you that that's possible. And so you have the same thing, Garden, able to run Linux workloads, able to run Windows workloads. If you could do containers in a reasonable way on OS X, Garden can actually run containers on OS X today, but it's sort of a lie. It doesn't actually isolate anything because the underlying primitives are not there. But at the end of the day, the API doesn't care. Okay, so this is how we run containers. Well, what do we run in containers? Well, two principal things. And this is probably true of almost any computing that you're going to do. We have tasks. What are tasks? It's a single unit of work, and we run it one time. We run these things all the time. We have, on Cloud Foundry, when you saw apps being pushed, those apps were going through a process called staging, where I look at an app and figure out what kind of runtime it needs, and I select a build pack that knows how to create that runtime and turn that thing into what's called a droplet, and we're going to create some droplets a little later on. But I only need to run that once, and it's done. Don't need to keep that running. Batch jobs. At some point in time, go get this data, process it, and put it over here, and then report back that you're finished, but you don't need to keep running. Do that all the time. Database migrations is another example. At a point in time, I want to run some Liquibase or some Flyway or some other migration tool to make something happen on my database so that my app can have what it needs. Want to run that. So these are all things that can run as tasks in containers. Then we have these things called LRPs. LRPs are long-running processes. And so we want to take a thing, and I want to run in copies of that thing. But I don't just want to run them. I actually want to run them forever. Until the code needs to change, this thing should run. It should keep running. It should be distributed across multiple cells, so that if one of the cells dies, then the thing is still there. And we want to monitor these things and restart these things. If the thing gets sick, I want it to come back. We saw that happen last night. This is what's going on under the hood. So let's kind of walk through this process of, I want something to run, how does it actually end up running? So we start at this front layer called the receptor. And the receptor is just the API to this whole container scheduling backend. So desired tasks that I want to run, desired LRPs, long-running processes I want to run, go in. And it's a very straightforward API. You have some JSON, and what does this JSON describe? Well, the first thing you see is a rootfs. What are the bits that I want to run? And here you say, oh, I'm running some Docker image. And then I want it to have some environment variables. I want it to have some share of the CPU, some amount of disk, some amount of memory. This container happens to run as root. It's privileged. And then I have action.
taking these bits in this rootfs, what do I want it to do? What are the types of things that Diego can run? Well, here's the list. Obviously, I can run a thing in a container, but I can also download stuff. If I want to get some code that's not inside the image and run it, I can download that. I can take the result of a task and post it to some URL. I can take several tasks and I can run them in parallel. I can take several tasks and run them in serial. I can measure things. I can report on things. All of these things can go inside of a container. You look at an LRP, and it's actually not that different from a task. Because really, the only difference is, instead of this thing running and finishing, we want this thing to run forever, and we want a certain number of copies of them. So it's really a special case. We add on at the top there the number of instances. So this particular thing, we want 17 of those. Odd number, but that's what we chose. We have some root file system. Again, that can be a Docker image, could be something else. Environment variables, resource allocation, and then you see 3 actions that you're interested in. Setup, run, and monitor. Sounds a little bit like what you do in a test, actually. I need to set things up that I need to be in place before I start running. So go get me some bits, for example, to run. Then start the process, so java -jar spring boot app.jar, something like that. And then monitor. So what monitor is going to do is just run a little program. Your choice, you can use the one that's built in, you can write your own. And that program is going to do whatever you tell it to do to determine, is this container healthy or is it not healthy? And what the basic one does right here is it say, is the thing still listening on its port? And it continually is polling. Is it still listening on the port? Is it still listening on the port? Oh, it's not listening. Hey, something's bad happened. I need to do something about that. And then we actually talk about things like the start, timeout, and ports. And this is not all the stuff that goes into the JSON, but these are the key things that you need to look for. And I'll show you a little bit more of this later on. So we've passed this into the API. This turns into what we call desired work, and the desired work lands on the BBS. So, hey, etcd, here's some work that we want to have happen. You keep up with the fact that I want this work to happen. Okay, done. So eventually, the brain is going to notice, hey, somebody wants to run some work. And so we go into this thing called an auction. And so on the brain, we have a component called the auctioneer. And the auctioneer is going to go out to all of the cells and talk to the cell's representative, short, we call it rep, and say, hey, I want you to bid on the right to run this work. A bid is essentially a report on, what is my available resources that I can offer to you right now? How much available CPU, memory, disk, and so forth do I have? And so the auctioneer is going to collect those bids from all of the cells. And then it's going to score those bids according to an algorithm and choose a winner. And that rep actually becomes the rep that is going to run this particular thing. And the way it happens, if you drill down into the cell, you've got 4 more basic components. So the rep knows about tasks and long-running processes. I know how to run the things that the API tells me about. But we know that the JSON that I pass into the API isn't the actual work that gets run. We know if we drill down into that JSON, we find some actions. And so the rep can talk to a thing called the executor, and the executor knows about how to run actions. But it actually doesn't know how to run anything at all. All it knows how to do is to ask Garden, hey, here's something that needs to run in a container. And Garden knows how to run things in a container in a platform-independent way. And then Garden Linux knows how to run things in Linux containers. And so me starting at the API saying, hey, I have some code that wants to run, we go through these steps of getting more and more specific about the thing that we want before we actually get to the work that actually ends up running in one of these containers. Why is this important? because it allows each of these layers to evolve independently, such that if we need to make changes at one of these layers, it doesn't necessarily affect any of the other layers. I can change things that I know about tasks and LRPs without changing how I deal with C groups and namespaces. You can imagine if those two things were actually bound together, it would be quite difficult to evolve the system, just like the systems that we build. So we've gotten to the point where we've sent in an API request, and it's gone through this whole auction process, and it's gone through this whole specificity gradient to where there's now this thing running in a container. What do we need to do next? Well, we told the BBS that we desired something to run. We also need to tell the BBS that there is, in fact, something running. And so the rep also has an additional job to say, hey, BBS, here are the things that are running in my cell right now. And so that goes in. And so then ultimately, what we're doing here through this kind of dance between stuff going into the BBS that's desired, stuff going into the BBS from the rep that's actual, is we're basically trying to ask the question, what's the truth? There's a very strong notion of truth and management of the truth inside of Diego, and all of that is being maintained in this component called the BBS. So we have two things that we care about. We care about the desired state of the world, all of the things that you've asked Diego to run in terms of your applications and batch jobs and staging jobs and so forth, and what's actually running. So there's two ways that this actually happens. One, you have events that get published. And so when I say the receptor tells the BBS about some desired work, that's an event that gets fired and captured by the BBS. When the rep tells the BBS about some actual work that's running, that's another event that's being captured and stored. Now, we all know, if you've spent much time with these types of systems, that sometimes events get lost. So that's a problem. And sometimes events take longer than they ought to arrive. And so there's often times where the system is actually not a true representation of the world. So on a regular basis, there is also a polling that goes out to ask, I think the state of the world based on all the events that I've captured is this. Is that actually true? And so we do that to actually keep the desired state and the actual state closer to what is actually the truth. And so then the thing that actually kicks this whole orchestration mechanism into action is then called the converger. What's the converger's job? The converger's job is to make the actual state look like the desired state. And it does that two primary ways. It tells the rep to stop doing things, and it tells the auctioneer to start doing things. And this is how everything works. This is how, when you push an app to Cloud Foundry, it actually ends up running on Cloud Foundry. Well, that's cool. I can write apps and I can run them on this platform. But as it turns out, Diego Cloud Foundry is also an app, and it needs to run somewhere. So how do I deploy that? Well, there's a Bosh under the hood. And I could give a whole talk. I could give days of talks on Bosh. We're not going to do that today. But Bosh is this thing that deploys and runs and monitors big things like Cloud Foundry. And it does that across multiple different cloud infrastructures. What problems does it solve? The things that you want to do with a large distributed system, like deployment and config changes and updates and upgrades with minimal downtime, zero downtime if possible, health checks, remediation, scale out, scale in, all the stuff that we talked about doing with our apps. We also want to do that with the thing that does that to our apps. And so there's a lot of stuff here. As it turns out, Cloud Foundry is sort of this big Star Destroyer thing, and it's actually kind of hard to deploy that. I mean, these tools make it incredibly easy compared to what it would look like if we didn't have them. But still, at the end of the day, learning these tools and learning how to use them so that you can make all of that magic that was happening last night on stage actually able to happen, there's a lot of challenges that go into that. And maybe you would actually like to play with this thing on the side and not have to like eat the whole Star Destroyer before you can ever get started. You know, maybe I just want to spin that up on my laptop and poke at it a little bit and see how it works and what it does. So how in the world do we do that? It is actually possible to take Bosh and deploy it on your laptop and take Cloud Foundry and deploy it inside that Bosh. But I said it's possible. You probably don't actually want to do that, especially not just to play with the thing, because you're going to be a long time before you get to something actually running. And so this is where we finally get to the thing 40 minutes in that we came to talk about, which is Lattice. And so this is why Lattice was born. Okay, what is Lattice? Well, go back to that original diagram. Remember we had some blue stuff and some yellow stuff and some red stuff? We're going to take the red stuff and we're just going to kick it out. And then we have Lattice, essentially. There's more to it than that, but basically what you're looking at is the container scheduler, the routing mechanism, the logging and metrics aggregation mechanism, without any of the policy and multi-tenancy and quotas and security and all that other stuff. Okay, cool. What makes that so much better? Well, because of how you can get one. How do I get a Lattice? Well, the simplest way is to Vagrant up your Lattice. And boom, you have all of that stuff running in a single VM on your laptop, and your laptop is still working. It's not like crawling and saying, leave me alone, don't run anything else on me because I can't take anymore. It's actually usable. And you end up with a single node cluster of all of that stuff, and you can start to interact with the system and run something that looks an awful lot like that Star Destroyer, and in fact, in terms of what's under the hood, is the same code as that Star Destroyer, and yet you can play with it in this way. If you want to go a little bit bigger, you can get a multi-VM cluster of that thing using another tool from the same company that does Vagrant called Terraform. And what Terraform will do is take that code and give you a cluster of machines on one of 4 environments right now: AWS, Google Cloud, DigitalOcean, or OpenStack. So I think that's enough talking about slides for a little while. Let's go do some stuff. So I need to pull up my little cheat sheet here. I'm not going to hide the fact that I'm working from notes because I got this all working exactly the way I wanted it to. And if I mess up, it might not work. So here we go. Let's get some terminal action. Now I'm going to do something really dangerous. I'm actually going to spin up Lattice right now, because I actually believe this is going to work. So what's it doing? So what Vagrant's doing is talking to VirtualBox, and Vagrant can talk to a bunch of things, but right now it's talking to VirtualBox, and it's cloning a virtual machine image that we happen to use as the base for Lattice. And so when it gets done making that copy of that thing, it's going to shove a bunch of code into it and start that code up, and it's going to tell me, hey, Lattice is here. And it's almost done, believe it or not. Put this into perspective. If you want to deploy all of Cloud Foundry from scratch, you've never done this before, you're looking at, if you're really good at it, an hour. First time you've ever touched it, right? So, okay. A little over a minute, we have this thing that's supposedly running. So this is, oh, okay, you can target this thing now. What does that mean? Well, first of all, we want to think about this in terms of a command line interface. So there's this thing called LTC. Some people call this Lattice, but that drives me insane, so I'm going to call it LTC. So LTC does a bunch of stuff. And if you look really closely, you see a lot of the words that I've been using. You see things like submit LRP, submit task, cancel task, delete tasks, cells, all this stuff. So this is just a command line interface that helps us to interact with all of those things that we just talked about. So what I want to do is I want to take a Spring Boot application and run it on this platform. So the first thing that I'm going to do is target it. So it always runs when you're in Vagrant mode, unless you decide you want to change that, on that IP address. If you're not familiar with zip.io, it's just a simple development DNS server that's sitting out there that IP address concatenated with zip.io resolves back to that IP address, so you don't have to create development DNS anymore, except this can be really flaky at times and it could completely blow up right now. So cross your fingers. You probably don't want to use this and depend on it a lot. But that's not our stuff, that's zip.io. So what do we want to do next? Well, I said that if you're going on Cloud Foundry and you do that CF push experience, you're going through that staging process, and that's running a build pack and creating this thing called a droplet. And then we take that droplet and we actually run it somewhere. Well, in Lattice, we've actually decomposed that into two distinct steps. Because what we don't tell you when you're looking at it as Cloud Foundry is that staging process, that's just a task. And that run process, that's just an LRP. And so Lattice knows about tasks and LRPs. So what we can do is, in the command line client, we've created this special command called build a droplet. And all that's actually going to do is actually run the task to make that droplet appear. So we're in the directory where my code is. And if you want to know what this application does, it doesn't do much. It has a / endpoint that puts a message called hello Spring Boot in there. It logs out a message every second that says hello and has some code to know how long it's been up and what index it is. Not a very fancy app at all. So I'm going to take that and I'm going to build a droplet. And I'm going to build that droplet, use the Java build pack, and then I'm going to point it at this code. And I'm going to find out that I did not give it a name. I told you if I don't do things right, that it doesn't work. And my terminal history is also bashed for some reason. Gotta love that. So we'll call it Lattice boot app, Java, target, Spring Boot. That should work. So it uploaded that jar file, stored it in a little blob store, and then it submitted a task to Lattice to actually run that build pack. Now, it's sitting there looking like it's doing nothing right now. And I am so happy that that next line came up. Because what just happened is that we went out and downloaded an image that we needed to actually run this task in. I said I needed a root file system. I had to go get that. So now I've created that container, spun up that build pack, and the build pack's doing just what it did last night, what it does every time. It gets the JRE, it calculates memory things, it does Spring auto reconfiguration if you want that, and now that droplet is created. And I can say LTC list droplets, and it can tell me, hey, I know about this droplet, here's when it was created, here's how big it is. So then I want to take that droplet and actually launch it. So I'm going to do a couple of additional things first. So here's a visualization on the bottom that tells me about my one cell, and it says it's empty right now. And I can also say LTC logs, and I'm going to talk about this thing called Lattice boot app. It says, I don't know about this, but if any logs show up, I'm going to tell you about them. And so now we want to run that thing. So LTC launch droplet. And this is just going to submit an LRP using the droplet called, so we're going to say, I want to call it Lattice boot app. I want to use the droplet called Lattice boot app. And I happen to want this one to run in 512 meg of memory. So it's spitting back logs to me on both sides. When you're actually starting the process, you get the set of logs between when the process is starting and when that health check thing, you see that health check passed, exit status, that means, oh, the thing is up and running. It's doing the thing that I want. But we're still getting on the other side a log statement every second that says, hey, I'm still here, I'm still here, I'm still here. Now, what else happened other than the fact that the container is running with my boot app in it and I'm getting logs? What also mapped a route for me? So it says, hey, the app is reachable at these two places, which means I can take that and I can go over to the browser and I can see my app. So that is actually getting the boot app running on Lattice on my laptop. Now what I'd like to do is show all the other things that it can do that requires me to have a little bit more firepower. So I have a larger Lattice cluster running on Google Compute Engine. So you see, instead of just one cell and a brain on one VM, I now have a brain plus 5 cells that are all going to do stuff. So how do I interact with this? Well, the way we interacted with the laptop was to target it. So we'll just do that. So this happens to be at a different IP address. Lost my, oops. And this one's secure, not really. You'll see the password later on, and you can do all sorts of terrible things to this cluster, but that's okay, because I'm going to delete it later. So don't get too excited when you see the password. Okay, so I am now targeting that. So if I turn on my visualization now, instead of just seeing empty, I now see empty, 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 empty. So all of my cells are now represented. What if I don't want to look at that on the command line? Well, as it turns out, there's a website out there that you can use called X-Ray, xray.cf. You go into xray.cf, you tell it where your receptor is, the username and password, and it's going to give you that same visualization of what's going on inside of that cluster. So let's look at logs again. Now, if you look at my droplets, I've already preloaded the Lattice boot app droplets, so we don't have to do that. We're just going to fire it up. Actually, I've already got this command back here, so we'll do that. Give it a little more real estate. Okay, so that's running. And if we look at X-Ray, cool, we got a little colored square. It shows me that that thing is there. But one app's boring, right? I want a lot more than just one of these. So let's go over to that. And I've got this one auto-refreshing, and we'll see why in just a moment. Let's get some scale. Let's try 40. Look at all those auctions. Those are completed auctions that have actually already, we've selected a cell to run the workload, and now we're just going through the process of what? We have to download the root file system to the container for the first time. So the first one's going to take a little while to start. Once we've downloaded it, we have it, and any workload we want to run on that root file system for the future after that, just going to use that thing. So you see that cell 2 already had that. So it's starting up a little bit faster. And now the other ones are finishing and they're starting to do their thing. We go over to X-ray and we see the same. We have a bunch of pulsing cells. Those are workloads that are coming up. We have solid colored ones that indicate that work is running. When we go over now to our browser, you're seeing that it's actually going from app to app to app. So that route, Lattice boot app with the IP address zip.io, is actually a route that is hitting that router on the front end, and we're now load balancing around to all the different containers. So as more containers start up, this number is going to be more and more unique over time as we actually move around and load balance through the cluster. And in fact, it really didn't take that long to start 40 Java apps. It's kind of cool. Okay, well, what else can we do? Well, I said this thing didn't just run things. It actually makes sure that they keep running. Now, I could do the shutdown trick that we did last night, but you've seen that. I want to do something a little bit more invasive. What if something really bad happened to Lattice itself? So let's say that somebody went in and decided, you know what? Cell 3 and cell 4, it's nice knowing you, but you need to go away. And so we're going to shut those down. One of them already disappeared. I can't even get back to the console. And you see that a machine disappeared, and Diego says, oh my goodness, a bunch of things disappeared. I need to make sure that those come back. And it's already balancing that work. Look at it. See? So not only can an app die, and the app is going to be restarted, but if parts of the infrastructure actually disappear, the platform is still going to do its level best to ensure that the desired state matches the actual state. And so all of that rebalancing is happening. We can go back in and we can bring these machines back. So we'll watch those boot up, as exciting as it is to watch machines boot. Interesting. Sometimes the command line visualization gets a little bit irritated. So that's a little bit better picture of what's actually going on. So you're seeing now that the machines are coming back. Now what it doesn't do yet is say, oh, machines are back. I'd like to balance everything back across the cluster. That's something that'll probably happen in the future. But what I can do now is, you know what, I know one of the reasons why I irritated it is because so when I rescale, you see that it's starting to take advantage of all of the workload that's available. And all the while, this just kept chugging. So I didn't show you this, but I never actually got a 404 or a 500 or anything when this was going on. You have to trust me on that. I'm not going to kill it again because I don't have time. Okay. So that was fun. But that's not real. Does anybody build Hello World apps for a living? Say, hey, my index is 1, my index is 4. I saw one hand go up. I was like, there are actually several people in this room that do build Hello World apps very often for a living, but that's another conversation. So I was spending some time with my son the last few weeks, and I had this sort of idea. So my parents came to town, and my dad got with my son and said, let's grow these crystals. And you get this box, and it has a jar, and it has a bunch of powder in it, and you pour some water in that thing and mix it up, and you let it sit and do nothing. And of course, to a 7-year-old boy, letting it sit and do nothing for days is like, it's the most excruciating thing he's ever gone through in his life. But his patience paid off, because at the end, he got these crystal things that he could look at and say, look what I made, okay? Now, where did Lattice's name come from? Lattice is a crystal structure. We have everything that we need in Lattice to do a bunch of stuff, but at the end of the day, when we get Lattice, it doesn't do much of anything except run stuff. We actually would like some stuff that we need to be running inside of that cluster. Now, if you looked at Cloud Foundry last night, you saw this massive marketplace of services. It's like I can get databases and message brokers and all sorts of cool stuff. Yeah, Lattice doesn't do any of that. What Lattice can do, though, is we did droplets, but it can also run Docker containers. And if you go look on Docker Hub, what does Docker Hub have? Well, it has databases and message brokers and all sorts of other stuff baked into images. So if you know what you're doing, some of this is in the Lattice documentation, but only for a handful of things. If you know what you're doing, you can take one of those images and shove it into Lattice, and it'll actually run for you. And we can get something that looks an awful lot like services. But I don't want to actually figure out the science of going from the kit to the crystal. What I need is a catalyst that's actually going to do this for me. So I was poking around over the last couple of weeks, and so I built this little thing called Catalyst. And what is Catalyst but something that looks a little bit like a service marketplace for Lattice? So let's play with that. Now, I don't want all this stuff, so let's get rid of it. Remove Lattice boot app. Get me a nice clean cluster. Okay, so I have preloaded on here, I believe, the droplet. Yes, I do. So let's launch that. And I'm actually going to put some environment variables to tell it about the Lattice that it's playing with. Now, everybody just humor me and don't do anything with this username and password until after the talk. The reason I say that is because I was actually watching a demo during a user group, and it was a speaker. He was from GridGain, actually, and he spun up this cluster of grid nodes, and it uses multicast, and he was on our network. And he said, yeah, I was at this meeting the other day, and somebody spun up a node and messed up the state of my cluster. And so I saw that as a challenge. And so I spun up a node on my laptop, and I messed up his demo. I realize now that that was probably a bad thing to do, because somebody's going to do that to me now. So please don't do it today. You can do it in another setting, just not now. So I'm going to pass in these environment variables, and I'm going to spin up this Catalyst thing. And there's the work spinning up. By the way, Catalyst is just a Spring Boot app. Imagine that. So we'll grab that. And so now I have this user interface, and it tells me that, hey, Catalyst is running. It knows about itself. But it also says, hey, look, I can go launch stuff like Spring Cloud Config Server and Eureka and Hystrix and MySQL and RabbitMQ and all sorts of fun stuff like that. So what I'm going to do is first show you what's going on. So here is the Spring Boot app that is Catalyst. And as it turns out, it has a controller that handles each of those different launch jobs. And I probably could have squashed this down into a single method that was all nicely abstracted, but I didn't have time for all that. So a little verbosity. But then in this thing called Lattice Launcher, if you look at what it takes to launch a config server, you see that I'm creating a desired LRP create request, and then I'm setting into it things like process GUID and rootfs and ports and memory and disk and environment variables. Then I'm telling it about a health check that I want to download, and I'm telling it about some Java code that I want to run, and I want to add an HTTP route. What is this? Well, Mark Fisher wrote this nice library called Receptor Client, which is just a Java binding to the Receptor API. So if you want to write your own code to be a front end to Lattice, knock yourself out. It's available. And so that's what this is. So all I did no magic other than I used his library, figured out what arguments needed to go into these method calls, and then tell the Receptor Client, which is just a wrapper around REST template, hey, go create stuff. And so you see config server, Eureka, Hystrix. It's actually quite simple to figure this stuff out. So what I want to do is spin up some scaffolding to run a couple of microservices. So I'll just run a config server and a Eureka, and let's get a MySQL database. Now if you look behind the scenes, there's X-ray. Get rid of that. See, Eureka's already come up. So it's in the process of actually launching all of these LRPs. Now, did MySQL actually work? Yeah, it just hasn't picked it up in the UI yet. There it goes. So we'll let all these things come up very quickly. For some reason, this visualization is, actually I know what it is. When you only have one thing running, sometimes it doesn't show up in the command line visualization. But it definitely shows up here. So our config server was the first to show up, but it's the last straggler. So while we're waiting on that, oh yeah? I'm not going to worry with it. So there's the Eureka that's running. It's not quite as slick as the one on Cloud Foundry, but it's close. Come on, config server, you can do it. Let's see what's going on in there. Cool thing is Catalyst doesn't actually hide anything from me. Everything's still available to me under the hood. Okay, maybe I just didn't wait long enough, because sure enough, there it is. And there's all my configuration. Now, another thing that I wanted to point out, go back to the Catalyst UI, the routes. You see all of my web apps have these cool HTTP routes. You look at MySQL, it has this TCP route attached to it. Now, MySQL is running in a container, and it's on a hidden network. I can't actually get to that thing in a very ready way. But we have a TCP router sitting on the brain, and that TCP router has a port mapped on it that's going to forward me in. What that allows me to do is the type of thing that I like to do a lot as a developer, which is type my password wrong. I can talk to that MySQL database, and I'm actually being tunneled through to that private network. So I can get to my database. Awesome. All right. So the next thing I want to do is deploy a very basic set of microservices. And some of you have probably already seen this app in the demo lounge. It's called Fortune Teller. Anybody seen Fortune Teller already? A couple people. You'll probably see it more than you want to by the end of the week. There's almost always one demo app at SpringOne that everybody uses, and by the end of the week, I don't want to see that app ever again. This might be that app. I hope it's not. But I get to show it to you first, so you're not tired of it yet. So basically what this is, we have a UI microservice and we have a service microservice. Wow, cool, that's fancy. Well, it needs to be fancy because it's a little bitty demo. And what's it going to do? It's going to give you back random fortune cookie fortunes. So the service is going to be responsible for managing that database and serving up a random fortune on demand. So I already have that here. So fortunes, random fortune, that's going to do a single entry page request, which is going to run a query that's basically going to select fortunes in order by rand. Okay, very basic stuff. Not very performant, but again, it's a demo. It doesn't need to be. So we've got that. Let's get out of MySQL for right now. And let's go into Fortune Teller. Go into my fortune service, and let's build a droplet for that. So build droplet, fortune service. So we're going to shove those bits up to the cluster and make a droplet out of that. Now I'm totally going to copy and paste from my cheat sheet for the run command because I'm going to ship a bunch of environment variables into this thing. And the reason I'm going to do that is because the fortune service needs to know how to talk to that MySQL database. Now, if you're on Cloud Foundry, you got this great environment variable sitting in your space called vcap services, a bunch of JSON that tells you about your database and credentials and so forth. Yeah, Lattice doesn't have that. And so, how do I know about my database? What in the system knows about that MySQL? The receptor. So we have a Spring Cloud connector. You'll probably hear about that a lot. Spring Cloud connector for Lattice knows how to talk to receptor and look for things and give you back things that it knows about that process. And as it turns out, that MySQL database has an IP address and a port that we know about, and it has environment variables inside of it that tell us about its root password and what database that we're running on. Not a production type thing, but it works for our purposes. And so we're going to actually give it the environment variables that tell it about the receptor, the username, and the password, and then tell it about its config server so that it can set everything else up. Now, I thought that this droplet would be finished by now, but it's taken a little bit longer. Sometimes this is happening to me. So we're just going to wait for a second. While we're waiting, we'll go build the droplet for the UI. Fortune Teller UI. I may have run into a network issue, but let's see. Let's see what happens to the Fortune UI. In fact, list, what is it? Oh, LTC list. I'm sorry. I'm having a moment. That's okay. Yeah, that Fortune service is still running. Let's see, logs. Yeah. So he's gotten hung up for some reason. So what we're going to do is we're going to cancel that task. Interesting. Those guys are already there. I'm going to try to start them. I'm actually going to really copy and paste now. So for whatever reason, my cluster is starting to yell at me right now, and I don't know why. But I'm going to fuss with it a little bit more. But instead of taking up all the time doing that, I'm going to tell you a couple other things. And then I'm going to come back to it. So the big question is, you've got this Cloud Foundry thing, and you've got this Lattice thing. When do I want to use one versus the other? So if you look at Cloud Foundry, it supports multi-tenancy, it supports resource quotas, role-based access controls, security groups, highly available components, zero downtime rolling upgrades of the platform itself, all this service marketplace and orchestration around services. You probably need all that stuff, and you're probably going to want to use, if you're in that kind of a world, CF. Lattice is a single-tenant cluster, so once you're in, you're in. There's no access control really to speak of. Everybody's cluster root. The networking is pretty much wide open. Not all the components are highly available. They're going to become highly available over time. There's no zero downtime rolling upgrade. You've got basically the whole red-black idea. I've got an old version of the cluster over here, spin up a new version, repoint the load balancer. That's how that works. And there's no data service, but you can see that we can overcome some of that stuff. So depending upon your needs, if you're a massive organization that needs all of the really strong enterprise features of Cloud Foundry, you can work with that. If you're just trying to get started, or you just want something to run on your laptop or run, for a small team off to the side to do some experimentation or other work, Lattice is a really good fit for that sort of thing. So with the time that's left, I'm going to mess around with a demo, but I wanted to invite David, who's sitting here. He's the product manager for Lattice, and I wanted to give him like a few minutes just to tell you if you want to interact with the Lattice team, or you have feedback or issues that you want to get addressed, how you can interact with his team. And you want the, actually that microphone is hot as well. So maybe they changed their mind.
All right. That's all you. Thank you. All right. Much better. We have a website, lattice.cf, that you can download our product. We've been working on this for about, 9 months now, along with the Diego rewrite. We sort of forked off from them to repackage Cloud Foundry. So we're trying to make something that developers can use to run microservices on at a much earlier phase in the software lifecycle. And we're just recently starting to work with the Spring team on integrating with the Spring Cloud Connector and sort of fleshing out what Lattice in production might look like. For now, we've really focused on sort of the local cloud desktop experience. But what we really strive for is to be able to stand up an environment in about 10 minutes, especially for the Vagrant experience. So if you're looking to check out Cloud Foundry in a sort of hands-on, smaller setting, we invite you to check it out. Come to our website, download it.
So is there a particular way that people can reach the team better than others?
We have our GitHub page. If you need issues, we have a mailing list, CF Lattice at list.cloudfoundry.org.
You're a good luck charm. The demo's working now.
Oh, that's fantastic.
What were you wanting me to send it to?
Well, lattice.cf is probably the best thing for everything.
Website, important, yes.
We have some documentation and links to our GitHub. You can track us down there. There might be an email.
You have issues.
Yes.
This is a good place to put stuff.
Thank you.
Okay.
Here you go.
So we've got 10 minutes, and I think I've actually got the demo working. I just needed David to come up here and put a little magic on it, and now it's there. So the fortune service we see is running in Catalyst. We see here are all the fortunes in the database. Random is going to give me back a random one. That's great. And it's also registered in Eureka. So in theory, I can now take the UI and spin that up. David, get back on stage. It works when you're here. So I think what's happened is that when I was really going crazy running a bunch of Java apps, I made one of my cells sick. And when I made that cell sick, if it keeps getting selected, this happens. So we selected a different cell and better things are happening, see? Cells don't normally get sick like that. This is my little experimental demo environment, so sometimes I break things. Okay. So Fortune UI is up. There it is. Yay. We have fortunes. And so how did that happen? UI is registered in Eureka, fortunes registered in Eureka, discovery happens, and just for fun, oops, I got rid of it. We can also prove that that MySQL database is actually where that data is coming from. So no smoke and mirrors. This is a real thing. And we're able to bootstrap that pretty quickly with Catalyst. So Catalyst is, I'm going to make it a thing. It's just not really a thing yet. So the code's still locked down in private. There's actually a Docker image out there if you know how to look for it and find it, but I'm not going to tell you to go use it because it's not even the latest code yet. So if we decide we want this to be more than what it is, we'll keep working on this. Eventually, this will become a part of the Lattice family of things. But for now, I just wanted to expose you to what's possible and let you know that this might be coming. And with that, I think we have only about 6 minutes left. But before I take any questions really quick, there are 4 other talks on the program that are probably going to touch Lattice in some way. 2 of them are on this track, 2 of them are on the data track. And they're all really exciting things, so I would invite you, if you want to go deeper with specifically things like Spring Cloud Lattice and Spring Cloud Lattice Connector, or how Spring XD is evolving to use things like Lattice as a container runtime, these are the talks that you're going to want to go see. So, and 3 of those are today. So if you just want to go all in on this stuff, there you go. So, like 6 minutes for questions. Make them fast. Looking for hands, and I'm not seeing hands. Yeah. It is actually possible, and oh, I'm sorry, yeah, I should repeat the question. So the question is, can I hook my debugger up to this thing? Absolutely, you can, and you do that through a thing called Spring Boot Developer Tools, which is going to show up in another talk. I don't know which talk, but probably one that Phil Webb is giving, so look for that, and you'll see exactly what I'm talking about. Other questions? Yes, no, maybe. Oh, yeah, sure. So this is a new hot thing. It's LTC SSH and then the name of the LRP, right? So what happened just now? There's an SSH daemon running inside of my container, and Lattice basically orchestrated a tunnel from here to there so that I can actually get into the Garden container where my code is running. And if I go a little bit deeper, wow, if that doesn't look like the inside of a Spring Boot app. So that's a relatively week, not even weeks old edition. Less than a week. So you get fresh bits here. Any other questions? Yes?
Without the Catalyst app that you created, how do you recommend creating or connecting a service?
Yeah, so if you go to the Lattice, oh, I'm sorry, the question is, no Catalyst, how do I do services? So if you go to docs and you go to Docker image examples, there's a bunch of LTC commands for things that are familiar, and really what Catalyst is doing is pre-baking this for you, but you can spin these things up. Once you have them spun up, you're sort of on your own as to decide how you want to connect to it, unless you use things like Spring Cloud connectors to abstract away the fact that you're talking to receptor to know where your MySQL database is, for example. But if you use TCP routes, one of the easiest ways is just to figure out what the TCP route is and connect to it. But you can also find out what the actual container IP import is through the receptor and connect to it directly without going back out through the front end. And we abstract all that away in connectors. And connectors will show up in I think the very next talk on the program in this room, if I'm not mistaken. Yes?
So if the role is SQL 5, why rely on Vagrant instead in the first place? Why not just start a strict approach to what you process?
So the question is, if we want to make it simpler, why are we relying on Vagrant? Why not just spin it up locally? Is that? Well, first of all, if I want to run Linux containers, I need to be on Linux. So if I did it just locally, I would basically knock out the Windows and OS X population. Now, you could go spin up your own Linux VM and install Lattice manually, but why would you want to do that if you could use Vagrant, which is Vagrant up? If you're already in a Linux box, then sure, you can actually download the Lattice bits and spin them up. I haven't done that personally, but I've seen people do it. And that's totally, if you go to manual install, there you go. Tells you the Linux that you need, what packages need to be there, download the tarball, set up these environment variables and run this installer script, and you're done. So That option exists. Okay, I think we're about out of time. I will be around all week if you want to talk more, but thanks for coming.